In this video, we're going to take a look at a Leetcode problem called shortest path in binary matrix. So we're given a 2D array, and 0 symbolizes empty and 1 symbolizes a block, right? So we're trying to find the shortest path from the top left, which is right here, and to the bottom right, which is right here. Basically, if we were to give a 2D array like this, the shortest path will be 2, right? So we can go from here to here because we can go diagonally, right? So this is one step, this is two steps, so we have to return 2, right? So we can go diagonally like this. We can go to left. We can go to bottom, left, right, top, top right, top left, bottom, bottom left, right? So basically, we're just returning the shortest path distance. And let's say if we were to give another 2D array, and 0 symbolize empty, 1 symbolize a block, right? So we cannot go to the block, we have to go to the 0 ones. So we can go diagonally, we can go to right, all four directions as well as diagonal directions, all four diagonal directions. So we have total of 8 directions that we can go. So in this case, we're just going to take this step, right? And then this is 1, distance of 2, distance of 3, distance of 4. So we have total of distance of 4, right? So in this case, we just return output 4. That's the shortest distance to go from top left to the bottom right. Because here you can see we can go diagonally. We don't have to take this step because in this case we can go diagonally, right? So diagonally has a 0, so in this case we can just take the shortcut. So let's take a look at more example here. Let's say we have another 2D array, right? And we're asked to go from the top left to the bottom right. And the shortest distance will be this way. You might be thinking that, well, what we can do is we can just focusing on doing a breadth search and focusing on the right, the bottom right, and then the bottom left, or I should say the bottom direction, right? Because those are only the 3 directions that we could think of to go to the bottom right. But the thing is that we also have to consider if we have a situation where we have something like this, where we are stuck on here, we can't go to the right, we can't go to the bottom left, bottom right, or we cannot go to the bottom. So what we have to do is we have to go up. So in this case, we have to consider all the directions, right? All 8 directions, because we can go diagonally. So in this case, we can go to the top, right? We can go to right, top right, bottom right, bottom, bottom left, left, and top left. We have to consider all those directions, right? So here, let's take a look at another example. Have to go from the top left to the bottom right. So here you can see if we were to implement breadth search, you can see we're just traversing level by level. So this is level 1, level 2 is right here, level 3 is right here, level 4, I believe this is also level 4 as well, and level 5, right, 5 right here, and then 6, and so on, right? So we basically, at the end, we're just trying to find all the possible ways to basically reach to the bottom right. And then what we're going to do is we're just going to use the breadth search to traverse level by level. And then for each coordinate in the graph, right, in the matrix, we're just going to do a breadth search for all 8 directions if they're in the bound, right? If they're not equal to 1, right? Because we know that 1 is basically means that basically means that we cannot go there, right? So 1 is blocked, right? So if it's 1 or if it's out of bound, or right, then what we can do is we don't have to worry about that. We don't have to traverse that. But if it is, then we have to add it to the queue, right? We have to add it to the queue, and then we want to make sure we update the distance, right? All we have to do is we just update the distance all the way to the bottom right. So this is 1, this is 2, and this is 3, right? And this is 4, right? This is 4, this is also 4 because you can go diagonally, and this is 5, and this is also 5. You can go diagonally like this, you can go diagonally like this, and then this is going to be 5, and then this is because you can go diagonally, and this is 6, 7, and 7 here because you can go diagonally like this. And then this is going to be 5. This is also going to be 5. You can go diagonally like this. 5 right here. And this is going to be 6. You can go diagonally or you can go this way. 7 here. And this is 8. right? And then this is 9, this is just basically 9, right? So we basically trying to do a breadth first search for each and every single level, and then we're just going to update its distance. Let's say we found that this distance, let's say it was 6, but when we get to here, and then we also have to traverse this position, right? Because this is also this can also be accessed. This path can also access this path right here. So we will also update the smallest distance to that position in the 2D array, right? So let's try to talk about how we can do this in code. So to do this in code, I have a 2D array here called directions, and basically we're adding all the 8 directions in a consideration. And before we start coding, I think it's good to look at the constraints. So here you can see this is the constraints, and each element is either 0 or 1, right? And then we also know that the length of number of rows that we have and number of columns is equal to each other, and the length of the grid is at least 1. And so what we can do is we can have a row length which is equal to grid.length, right? We're gonna need it later, and we also have a column length, right, which is equal to grid at 0.length. So what we have to do is we don't have to do the base check to see if row length or the column length is 0, because the constraints already give us that the length is at least bigger than 1, bigger than or equal to 1. So what we have to do then is we have to consider, well, we are going from the top left to the bottom right. So could there be a situation where the top left is equal to 1 or the bottom right is equal to 1, right? So if those are blocked, then there's basically no starting point, right? There's basically no starting point or end point, because the designation and the starting point is blocked, right? So or is blocked, right? So what we're going to do is we're going to say grid at 0 if it's equal to 1, or if we have grid at row length minus 1, the last element, right? So the bottom right element, so column length minus 1 is equal to 1, then we can just return -1, because there's no path, right? If there's no path, then we're just going to return -1, just like it says here. So return length of the shortest clear from the top left to bottom right. If such path does not exist, return -1. So then what we had to do is we're going to create a queue, right, to store each level's element, the coordinates, right? So we're going to do using breadth first search to traverse level by level. So we're going to use a queue, and the thing about this part is that we have to store the coordinates, right? Because usually we store the elements, but this time we have to store the coordinates, right? The which row and which column is going to be added to the queue, so that we're going to traverse later, right? We're going to do this level by level. So then what we're going to do is we're going to use a 2D array, right? Integer 2D array to store the shortest distance from the top left, right? So from the top left, we're going to have a 2D array that has exactly the same size as the given grid. And for each and every single element, we're going to store the distance from the top left all the way to the current element, right? So if it's blocked, then we're going to store it. We're going to change it to something like null, or to an integer.max value, right? So to symbolize that this is a blocked place, we cannot go there, right? And if the current element is, let's say, is equal to a empty, right, is equal to 0, then what we're going to do is we're just going to update the current distance. This is distance 1. To go to here is going to be 1, the previous distance, plus 1, right? It's going to be 1 plus 1 is 2. So in this case, we have 2 here. So at the end, we're just going to return the last element in the array, right? So the distance. So what we're going to do is we're going to have an integer array, and we're going to call it visited. We're going to have a size of row length and then column length. Okay, then what we're going to do is we're just going to start to add the first element, or add the current element, right? So we're going to have the grid. We're going to have queue.add grid at basically it's going to be new array. We're going to add the coordinates onto the queue, right? So it's going to be 0, 0. This is going to be the coordinate. And then for the visited, because we're visiting that element, so we're going to mark that. So visited at 0 is going to equal to 1 because we have a distance of 1, right? Starting is going to be 1, so distance of 1. And then what we're going to do is we're just going to start to perform the BFS, right? So while Q is empty is equal to false, right? It's not empty, then we're just going to remove the first element. So it's going to be a array, which is equal to Q.remove. Once we remove the first element off the queue, right? We're getting the first element off the queue. Then what we're going to do is we're just going to perform this breadth first search, right? So we're going to get all A directions, right? So we're going to have a function that get all the neighbor nodes and then check to see if they're out of bound or either inbound or either out of bound, or and then what we're going to do is we're just going to update its distance if it's not out of bound or if it's not a blocked node, right? If a place is not blocked. So what we're going to do is we're going to get the current row. So current row is equal to first at 0. Integer current column is equal to first at 1. And then we're going to have a method that basically iterates and get all the 8 directions to check to see if they're out of bound or didn't satisfy the condition. So we're gonna call it get neighbors, and then we're going to pass in the current coordinates. In this case, the first. It will give us a list of coordinates that satisfy our condition. Then for each coordinates, we're going to have a neighbor. The row is equal to num at 0, right? The first element is going to be the row, and then we're going to have a column, which is num at 1, which is going to be the column, right? The second element is going to be the column. I guess it's good to put it right here. So, so array at 0 is going to be row, and array at 1 is going to be column. Okay. So once we have the neighbor row and the current neighbor row and current neighbor column, all we're going to do is we're just going to update its distance. So if we didn't visit that, right? Let's say visited, because in integer array, by default they're all null, right? So if we have a situation where the visited is null, right? If it's null, then all we have to do is we just have to update the distance based on the current row and the current column from the visited array, right? So if the current visited at neighbor row at neighbor column, current neighbor row and the current neighbor column is null, or if we have a situation where the visited, right, at neighbor row, let's turn it into a variable. Actually, let's make it so neighbor distance is equal to visited at neighbor row and neighbor column, and if neighbor distance is equal to null, right, if we've never visited that before, or if neighbor distance is bigger than the current distance plus 1, right? So current distance plus 1 is going to be the distance if we were to go from the current element to the neighbor element. So in this case, we have visited at current row at current column plus 1. So if that's the case, then what we have to do is we have to update that. So what we're going to do is we're going to say visited at neighbor row at neighbor column is equal to visited at current row at current column plus 1. So we're updating that to the shortest distance, right? Then what we're going to do is we're just going to return the last element of the array. So in this case, it's going to be the grid row -1 and the column -1. But one thing that I forgot to do is we have to add the current element onto the queue. The reason why we're adding the current element on the queue rather than adding it here is because if we found out that the current element didn't really satisfy this condition, right? We only have two conditions that satisfy. Either the current distance never visited. If we never visit that element, we definitely want to add it onto Q, right? So that we can traverse that for the next level. If the current element is like actually bigger than the if the neighbor's distance is actually bigger than the current distance plus 1, then we also have to update the current neighbor distance, right? Then we also have to update its neighbor's distance, right? So that's why we have to add this element. Either we re-adding that element onto the queue or just adding this element onto the queue. So at queue add, we are basically just going to have an array. We're going to put the neighbor row and the neighbor column. Okay, so we're adding that onto the queue. Okay, and then what we're going to do is at the end we're just going to return the last element because that will give us the shortest distance, right? So now we have to implement this get neighbor method. It takes a integer array, which is going to be the coordinate. So integer array is let's call it the coordinates, right? So coordinates. So I'll just kind of call it coord. We're going to have a global variable called matrix or array. So let's just call it matrix. And we're going to put matrix is equal to grid, right? So we have a matrix that's equal to grid, and then so that we can access it here, we don't have to pass that in every single time. And then basically we're just going to iterate. At the end, we're returning a list of integer, right? So integer array of those qualified coordinates that we're going to iterate and update their distance. So we're going to have for each, basically for each integer array in the directions, right? So in this case, what we're going to do is we're just going to see, right? So if num, so we're going to have integer row is equal to num at 0, column is equal to num at 1, and if row is less than 0, or if row is bigger than or equal to matrix, right? The global variable that we're talking about, matrix so dot length, then we can just then we can just continue, right? So continue. If we have a situation where the column is less than 0, or if the column is bigger than or equal to matrix at 0 dot length, right? If we were out of bound, then we're just going to continue. So that's our base case. And then what we're going to do then is we're just going to focusing on check to see if the current element is blocked, right? So if matrix at row at column is equal to 1, then we also have to continue. Now this is going to be the directions, right? So this is going to be the directions, but we also have to add it onto our coordinate because in this case you can see this is -1, right? So this is -1. If the current element, let's say, is 2 and 1, then if we were to go to the top left, right, that's going to be 2 plus -1, which is 1. 1 plus -1 is going to be 0. So that's how we go to top left. So what we have to do is we have to add that. So it's going to be core at 0 plus core at 1. So in this case, num at 1 plus core at 1, coordinate at 1, and then num at 0 plus coordinate at 0, right? So then it will give us the either we qualify or not. Then what we're going to do is we're just going to add it onto the list because now it's qualified, right? So we already did our check. We're going to have a list is equal to linked list. We're going to say list.add. Okay, we're going to add new integer. We're going to say row and column. This will basically add the coordinate onto the list. At the end, we're just returning the list so that we can iterate at the here, right? So at here, right? So yeah, basically at the end we iterate and then we get a job done. So let me just summarize this real quick. So basically we have a 2D array that's a global variable that's basically equal points to the grid, and we have a length, row length, column length, and if we have a situation where the first element or the last element is equal to 1, which is blocked, then there's no path, then we're going to perform breadth first search. So perform BFS, right? We're going to have a queue that stores the array, the coordinates, and then we're going to have this method that basically checks if the coordinate is valid. If it's valid, we're just going to make sure that we're updating its neighbor's distance. Then we can continuously do the job until we get to a point where we get the shortest distance for every single element, including the last element. Then one thing we have to do is we have to return the visited, right, instead of the grid, because we didn't change anything, we didn't touch anything for the grid. So in this case, row length -1 at column length -1. So there could be because this is a 2D array, there could be a situation where we didn't visit that node, right? Then if we didn't visit a node, then what we have to do is we have to make sure that if a result is null, then we just return -1. Otherwise, we just return res, right, which is the integer value. So let's try to run the code, and let's try to submit. And here you can see we have our